All right, well, I think what I'm going to do right now then is I'm going to go ahead and talk about UML. All right, UML actually for UML means a lot of different things, but we're just basically creating UML class diagrams. So if you read the lecture material or if you watch the video that Professor Schumann put together on UML, there's all kinds of different UML diagrams. We're only doing the UML class diagrams, and those aren't actually all that hard. So somebody asked the question, why do the assignments feel so tough and scary? Okay. Well, I would argue that assignments only feel tough and scary if you haven't practiced the Python. Okay. If you're up to speed on your Python and you've been practicing it the way that I said, and nobody's saying practice for 6 hours a day. I mean, if you put in probably 15 minutes of typing where you're typing out Python a day, you're going to be so much further ahead of the average student in this class would be my guess, okay? The common thing that students do is they scramble and turn in an assignment on Monday, and then they're feeling kind of like drained and burned out or whatever. So they listen to the lecture on Tuesday, they don't do any Python, they come on Wednesday, or on Wednesday they don't have lecture, but they're still kind of recuperating. Thursday, they listen to the lecture, and then they really don't start even thinking about the assignment until Friday or Saturday. Okay. And so again, that's just not, if you want to get good at something, you need to practice it all the time. Okay. So a lot of the easy things that I've showed you should be second nature by now. Like if I were to say, write a constructor, you should just like that be able to say, okay, I'm gonna go write a constructor and not even really have to think about it. But I'm telling you, this assignment is actually not that tough or scary. I think you can do the entire thing in about 100 lines of code, which, that's not that many lines. If you spread that out over 7 days, that is what, just like not even 20 lines of code a day, 15 lines of code a day. I mean, I think anybody can write 15 lines of code in one day, okay? All right, so UML diagrams. Okay, so basically what we're going to do is I'm going to pull up, let me share my screen here. Share screen. Okay, so I am going to pull up a class. Let me see if I've got a class that I can use. Let's look for something. What do we do in lecture 5? Okay, we created this circle class, okay? So I'm gonna show you how you can basically create a UML diagram out of this circle class, okay? And the purpose of a UML diagram is to it serves a few purposes. Number one, it's to document the classes, their methods, their attributes, their behaviors in kind of a visual way so that you can sort of see how your classes are all going to work together, all right? And a lot of times what people like to do is they like to build the UML diagrams before they start writing any code. So it's kind of like an architecture or planning kind of a thing. So if somebody were to come to you, just kind of like the assignment, right? So if somebody was to say, here's this assignment and we're starting our own cloud computing company and they give you all this stuff, then before you start slinging Python, you can say, all right, I'm going to actually just create a little diagram to kind of have it straight in my head what the classes are that I'm going to need, whether I'm going to need multiple classes, whether I'm going to need subclasses and all that kind of stuff. And I'm going to kind of write it all down and put it in a nice visual format so that once I have it, then it'll be easy to start writing code, okay? So I'm going to kind of do it the opposite way. I'm going to start with some already implemented code right here in this circle class, and I'm going to show you how to create a UML diagram from this. And I think that will help kind of illustrate the concept, okay? So a UML diagram, there's not one set format for it, okay? This isn't something that like you have to do it this certain way. So I'm going to just show you the way that I do it, but they're all going to look similar, but not all exactly the same. Okay, so basically what we're going to do is we're going to create a table. Okay, so let me get my ribbon back here. So I'm going to insert a table, and I'm just going to make it 1 column by 3 rows. Okay, so there we go. So I have this table. All right. Now what I like to do is in the first item here, I like to list the name of the class. So in this case, we have the circle class. All right. In the second row is where I'm going to list all of the attributes of the circle class. And in the third row is where I'm going to list all of the methods of the circle class. Okay. So if we go back to here, we can see that our circle has, well, it really only has one attribute, radius. Okay. So I'm going to go ahead and stick radius in here. Okay. And then we see that there are a few different methods. There's this constructor. So there's the init method. There's the compute area method, the get radius, the set radius, and the get area. Okay. So I'm going to list all of those in here. Okay. So I'm going to say init. Okay. There was get radius. And now remember, methods should have the parentheses. Set radius. Okay, and what did I miss? Compute area and get area. Okay, so underscore compute area and get area. Okay, all right, so this is the beginnings of our UML diagram. Now, this isn't all that we need to do, okay? The next thing that we need to do is we need to indicate which items in here are public and which items are private, okay? And so the way that you do that in UML is before the name of the thing, so in this case radius, use parentheses, and you're going to either use a plus or a minus sign, okay? The minus sign means that this is a private attribute or a private method, okay? So I will ask the question, if I was going to label the, sorry about this. Okay, if I was going to label the methods as private, which ones of my methods listed here are private? Can anybody answer that question?
Compute area.
Yep, compute area, okay? And it's easy to tell in Python because you've got the double underscores at the beginning. All right, so that one's private, okay? Now, what about all the other ones? The other ones are all public. So for public methods, I'm going to just do a plus sign, okay? All right, so I'm going to go ahead and put in all these plus signs. Okay. All right. So that is now I have communicated public and private. All right. And now there's one other thing that we need to do, and that is we need to indicate the type of data that we're expecting. Okay. So a radius, all right, is a radius. What kind of data is a radius? What kind of data type would that be? Okay, an int. Yep, an int, or it could be a double, perhaps, like if we want our circle to have a radius of 7.3. Yeah, it could be float, okay? So either float or int, okay? We'll say float, okay? All right, now for our methods in general are going to return things, okay? But sometimes they don't return things. So for the methods, rather than listing the type, because the method doesn't really have a type, we're going to list the return type, okay? So what is the return type of underscore init underscore? Okay, you say, somebody says string. Somebody says question regarding minus and plus. Can it change, and can you include a UML legend? No. The standard is minus or plus. That's understood in a UML diagram. You wouldn't say, all right, I'm going to use a star and, the pound sign and then give you a legend. That's not how it's done. It's always minus or plus. Okay. So for the init class, so since init is a constructor, you could argue that this actually returns a circle, okay? And that would be fine. All right, but that's also a little bit confusing. You could argue that, well, actually it doesn't really return anything because we never explicitly say to return anything. So I could put none. But what we're going to do, and what I'm going to recommend that you do, is for a constructor, you just don't put anything. Okay, so we're going to just leave that one blank. All right, now how about get radius? What kind of data does get radius return? Okay, people say int. Okay, well, given that we have marked the private attribute radius as a float, I'm going to say that get radius must also return a float. If I had made this an int, then it would make sense for this to be an int. The point is that they should probably match. Okay. All right. What about set radius? What does set radius return? Any guesses? Nobody wants to guess?
The radius.
Okay. Does set radius return a radius? Somebody says nothing. Yeah. Okay. Set radius doesn't really return anything. Okay. Now we could have it return true or false. A lot of times people for their setters will like to make it return true or false. So like if it was able to set it correctly, it would return true. Otherwise it returned false. But we haven't really done that in this class. So in the case of this code right here, set radius actually doesn't return anything. There, you notice there's no return statement. Okay. So we're just going to go ahead and leave this one blank. Okay. Don't need it in there. Okay. All right, what about compute area? What does that return? Here's compute area. Okay, somebody says float. A couple of votes for float. Okay, float. Well, do you see this compute area returning anything? Okay. Yeah, somebody said blank. This compute area actually isn't returning anything. It's just setting an attribute. Okay. And so I'm going to actually say compute area. Or just leave that one blank because that one doesn't return anything. All right. What about get area?
Float or int.
Okay. Yeah. And well, it's almost certainly going to be a float, because the area involves pi times some stuff, right? And pi, as we know, is at 3.14 whatever. So this one's going to be a float for sure. Okay. And one of the things that we'll notice if we look at our circle is, does it look like we missed an attribute somewhere? Does anybody see it? Look at this guy right here. Okay. So we didn't explicitly set the area up here in the constructor. We set it down here, okay? But this is definitely an attribute of the class, underscore underscore area. Okay, so we need that one. Okay, now one of the things that I should point out is that you can, if you want to be absolutely correct, you should probably put in the double underscores, okay? Because really that's what these items are called, okay? So we'll go ahead and do that. We'll put in double underscores for radius and area, okay? All right, so this is looking pretty good. Now, there's still one thing that we're missing, okay? And that is, notice that our functions right here are functions that accept arguments. The arguments aren't listed here, okay? And to do a UML diagram properly, we should actually have the items, the arguments listed, okay? Now for UML diagrams, because self is kind of like this weird sort of thing, we don't bother to include self really anywhere, okay? We're just kind of ignoring it. But for all the other arguments, we need those, okay? So if we look back here, our constructor has this radius, okay? So basically what we'll do is we'll come in here and we're going to use the same kind of a syntax that we're using up here, just without the minuses or plus. So we'll say radius is an argument, and then we'll do colon, and then in this case, it will be a float, okay? So it's almost like you're kind of writing Python, but you're sort of doing it in reverse, right? Usually you would kind of list these in a different order, like, right? Well, I guess in Python you don't have to declare a data type, but if this were another programming language, it's usually the type of the data and then the name of the variable. We're kind of doing it in reverse, okay? Now get radius, okay, doesn't actually accept any other arguments, so we can leave that one alone. But set radius has this R, okay? So I could just do R if I wanted to, or I could say radius because it's a little bit more descriptive about what's going on. Okay. And then does compute area have anything? Compute area doesn't have any arguments. So none of the other ones have any arguments. Okay, so this right here, basically, I'm going to call this my UML diagram for the circle class. Okay. Does anybody have any questions? Now, one of the things that I like to do to make it look a little bit neater is I'm going to drag this over so that it's a little bit smaller. And then I'm going to drag the whole thing and stick it right here in the center of the page there. Okay. So there we go. So now I've got my circle class. Okay. Does anybody have any questions about that so far? I mean, it seems relatively straightforward, I think. I'm pausing to see if anybody has any questions. Okay, so now we need to cover the case of somebody says why radius has underscore despite, well, because that's the actual name of the variable in our class, right? So in Python, because Python doesn't really have private variables, it has this double underscore convention that kind of makes it private, but doesn't really. It's a little bit redundant, admittedly, okay? But in other programming languages where it doesn't have this convention and you legitimately have public and private things, then it's more important. But in the case of Python, you're correct in that it is sort of redundant. But to be thorough, the name of the actual attribute is underscore underscore radius. It is not just radius. So that's why we see if we actually go look in the class, you see that the name of the attribute here is actually underscore underscore radius. So that's why we did it like this. Okay, all right. Now, suppose, let me find a different class here. Let me see, what do we have in lecture 6? A rectangle, okay, that's not what I want. How about lecture 7? Nope. How about lecture 8? Ah, okay, this one is a good one. All right. So now here we have a situation where we have a class COD character. I guess this was our Call of Duty thing that we did. Okay, we have this Call of Duty character class, but one of its attributes, this underscore underscore weapon, is another object type. It's not just a simple data type. It's this weapon class. Okay, so if we were going to go ahead and create a UML diagram for this, how would we do it? All right, well, let's just kind of work through the same way that we just did. All right, so the first thing I'm going to do is I'm going to create a table that's 3 rows by 1. All right, we'll do COD character class like this. Okay. All right. Now, attributes, I have a name. All right. And this looks to be public. All right. I have a weapon. That looks to be private. And that looks like all I've got. Okay. So this one should be relatively easy. So for name, weapon, thanks autocorrect. I appreciate that. All right. So name is public. So this is going to be a plus sign. Okay. And name is going to be a string. So you can put string or you can put str. It doesn't really matter. Okay. As long as it's obvious what you mean. Okay. Don't just put s. Okay. Str string, probably fine. Okay. Weapon is private. So it's actually underscore underscore weapon. All right. And what is the data type of weapon? Okay. Somebody says str. Okay. Any other guesses? Let me go back to the code.
Class.
Okay, somebody guessed class. All right, good guess. What's the actual data type though? Okay, somebody says object, also a good guess. Yes, okay, it is its own data type, but what is its data type? Its data type is weapon. Okay, remember, when we create classes, we're creating our own data types, okay? So there's already a data type for string and Boolean and all that kind of stuff. We're creating a weapon data type, okay? So that's what this whole thing is. So weapon is actually this underscore underscore weapon. Its data type is weapon, like that, okay? All right, now let's look at the attributes. What attributes do we have? We've got init, we've got str, we've got get weapon, and we've got set weapon. So let's go ahead and list those. Init, str, get weapon, set weapon. Okay. Now, init, is init public or private? Okay, yeah, of course it's public. It has to be public. It's a constructor. Okay, so that's public. All right, what about str, public or private? Okay, yep, str is public. All right, how about get weapon? Public, set weapon, public. Okay, so all of our methods are public. Okay, and now what does init return? Okay, we're going to say that returns nothing. All right, what does str return? Yep, okay, this returns a string. Always returns a string. Okay, what does get weapon return? A weapon. Zizo, you are very, very set on your straws, okay? Weapon is not a string. Weapon is a weapon, okay? Remember that. Okay, and then what does set weapon return?
Nothing.
Yep, set weapon doesn't return anything. So we're just going to leave that one blank, okay? So now the last thing that we need to do is we just need to do our arguments, okay? So let's see. Init takes a name and a primary weapon. Okay, so we'll do name, str, comma, primary weapon, colon, weapon, like that. Okay. Str shouldn't take any arguments because it's just the self. Get weapon doesn't take any arguments. Set weapon takes a weapon argument. So we can do, where's my cursor? There we go. So weapon, colon, weapon, like that. Okay. All right, so our Call of Duty character class is looking pretty good. All right, now we have a problem. All right, in this great Call of Duty, why is this stupid thing not dragging? There we go. Okay. All right, the problem that we have is that we now have a data type weapon that we have not yet accounted for. Okay, so we need to create another table to deal with this weapon. Okay, so I'm going to create another 3x1 table. This will be our weapon class. Okay, and I think, yep, we've got it defined here in this file. Okay, so this one's nice. It has name and DPS are the attributes, and then it's got init, str, and EQ as the methods. Okay, so we have name and we have DPS. Oh, come on, autocorrect DPS. All right, and then we have underscore underscore init. We have underscore underscore str. We have underscore underscore EQ. Okay, and all right, so the way that we set this up is that we've made everything public, basically. So this entire thing is going to be public. So we'll just go ahead and put in a plus here. A plus here. A plus here, plus here, plus there. All right. Name we know is a straw. Damage per second. I don't know. This could be an int or a float. We'll say it's an int. Okay. A init. That's not going to return anything, but it's probably going to take, yeah, it takes name and DPS as arguments. Let's just go ahead and add those in. Name, str, DPS, int. Okay, str doesn't take any arguments, and EQ does take. Okay, this is a good question. What does EQ take? It takes this other, but what is the type of other? Weapon, yes. Excellent. Okay. This is the other colon weapon, like this. Okay. All right. I think that pretty much does it for our weapon class. Okay. Now what we do, okay, is I'm going to actually take this and I'm going to drag it up so that it's right next to it up here. Oh, how about the return? Yes, thank you. I forgot the return, okay? So init doesn't return anything. Stro returns a string. And EQ, what does EQ return? Ooh, true or false Boolean. Yes, absolutely. So it's Boolean. Okay, great. All right, now typically the way that you do this, I'm actually kind of running out of real estate here. Let me see if I can... How do I change the page to landscape? Do I do it here in page setup? I'm running out of space here. Here we go. No, that doesn't look right. Oh, well.
I think it's in layout.
Yeah, what I'll do for right now is I'll just squish this down a little bit. Okay, so it looks terrible. But all right, so basically what we need to do is in order to show a relationship between these two classes, we actually have to connect them with a line, okay? So I'm gonna go over here to draw. No, I'm gonna go to insert and I'm gonna go to shapes. And I'm just gonna make a line between these two classes. Okay, there we go. That's not very thick. So maybe I'll... As you can see, I am not a Microsoft Word connoisseur by any stretch of the imagination, but here we go. Okay, so let's make it a little bit thicker so we can see it. There we go. Okay. All right, so now we got a nice thick line, okay? And so that right there shows that, oh, okay, when I see weapons in here, now I've got some way to... Does the line type matter? Yeah, the line type does matter, so it should just be a solid line, okay? Don't use like a dashed line or anything like that, because for more complicated class hierarchies and stuff, there are like dashed lines that actually mean something. So just use a solid line, okay? All right, so that is basically all that we need for this particular problem. Now, there's actually one other thing that we need to talk about, and that is how do you deal with inheritance in a UML diagram? Okay, so suppose that I were to come down here and say, all right, I'm actually going to create a new class called gun, which is a subclass of weapon. All right, and this one's going to have a constructor, and this will take name and DPS, but it will also take ammo type. Okay, and so I'm going to do, oh, here's a good review question. Does anybody know how I can call the constructor in the superclass? Does anybody remember that from last lecture? Okay, not dot super. Okay, I'm just going to go super, and then I'm going to go dot underscore underscore init underscore underscore, and then I'm going to pass in self name or sorry, not self, I'm going to pass in name and DPS. Okay, so that's how you do it. And then I'll do self dot underscore underscore ammo. Actually, I'll just make this public. So I'll do ammo type equals ammo type. Okay, so now I have a subclass. All right. So going back to my UML, the way that I account for that is I need to create another class box in here. So I'm going to create another 3x1 table. Oops, not there. Okay, so let's see, 3x1. All right, so I'm going to say gun class. Okay, and this one has a name. Okay, so now this is something that we need to point out. All right, if you'll recall from inheritance, the inheritance lecture before, this gun class actually inherits all of the stuff from weapons. So it has name and DPS and all that kind of stuff, and it has these methods. All right. So when we make our UML diagram, we're not going to relist all of this stuff. Okay. We're only going to put in the things that are unique to the gun class. Okay. So in this case, even though name and DPS are technically part of a gun, we're not going to bother to relist those. So instead, what we're going to do is we're just going to say, all right, there's only one additional thing, and that's ammo type. All right, and that is, I guess, a string. And we actually haven't created any new methods. Okay. Well, I guess we created a constructor, so we better list that one down. Okay, so underscore underscore init, and then we have name, DPS, int, and ammo type string. Okay, and that doesn't return anything, so we'll just leave that as is. Okay, so that's my gun class. All right. Now, the way that we draw a superclass subclass relationship in our UML diagram is we use a open triangle. Okay. Oh crap, I don't know what I just did. Let me undo that. Okay, so I'm going to attempt to move this over a little bit. Okay, good. That let me do it that time. Okay, so here's what we're going to do. We're going to insert a shape. All right, and I'm going to use this triangle shape. Okay, and what has to happen is this triangle needs to be pointing at the superclass. Okay, so see how I have it pointing at the superclass? All right, and when I format it, all right, I need it to be, it shouldn't be filled. It should be, I'm not exactly sure how to do that in Word. Because I
don't go to shape fill.
Shape fill, where is that?
It's up at the top.
Fill, okay, there we go, no fill, thank you. Okay, and let's go ahead and make it a little bit wider so it shows up a little bit better. Okay, so now, the point that I want to make is that when we're demonstrating a superclass-subclass relationship, it's going to be like a triangle, and it needs to not be filled in. When you have it filled in, that actually means something else, okay? So for this purposes, and then what you need to do is you need to have a line, okay? So I'm going to insert a... Why is this grayed out? Again, like I just don't know how to use, there we go. Okay. So I'm just going to do a simple line, and I'm going to draw it from here to here, kind of connecting the two, and I'll make it a little bit fatter so it shows up a little nicer. Okay, there we go. So that's our diagram, okay? So when we have a line like this that goes and ends in this triangle, then that's how we know that gun is a subclass of weapon, okay? Can it not be an arrow? Well, the problem with an arrow is when I was messing around with this earlier, let me show you what happens if I try to do an arrow, okay? At least in Word. Now, if you have some, like if you have Visio or something like that, maybe you can get away with an arrow. But like if I try and use this, okay, this just makes like a big, like blocky looking arrow, okay? So, I don't know, it just doesn't look quite right to me. I suppose that if you like didn't fill that in, maybe it would be okay. But this is the way that it should look, okay? And then if I tried to insert just like, if I try and insert this kind right here that has like the arrow on it, the problem that I ran into was, so when you format this, right, you can, the only arrow types that you don't really have, see, you don't really have an option to, at least I can't, where is the arrow? Okay, here's the arrow size. So we can make it a little bit bigger, but we can't make it very large. Okay, so that's one thing. And then I'm not quite sure how you would make just the arrow transparent, because again, the arrow can't be filled in like that. Okay, so again, depending on what tool, you don't have to do this using Microsoft Word. You can do it in PowerPoint. You can do it in whatever tool that you want. You can draw it out by hand with a magic marker and crayons if you want to, okay, and then take a picture of it with your phone. The point is that it needs to be it needs to be like this, and it needs to not be filled in, okay? And so your question of can it not be an arrow, that's why I didn't use an arrows, because I couldn't figure out how to make the head not filled in. If you have a way to make an arrow where the head is, not filled in, then by all means use that, okay? All right, so that should be enough information to get you started on your assignment. So really quickly, what I want to show you is, without even writing a single line of Python code, let me go ahead and create a new document here, okay? Without writing a single line of Python code, I can come in here and look at this assignment and say, all right, I can actually start building my UML diagram, okay? Because here we go, like we see that each customer, okay, the system must track the customer's name, phone number, email address, and if the customer has a corporate discount. Okay, that's easy enough to do. So if I go back to my blank document here, I'm going to go ahead and insert. So I'm going to have a customer class, and I'm going to have a name and an email and a phone and a discount. And what else was there? Oops. Let's see. Name, phone number, email address, and if they have a discount. Okay, so I got that. Each customer will only select a single VM. All VMs have a monthly rate, which includes memory and some storage. Okay, so this to me looks like a VM is going to be an attribute of a customer. Okay, so probably, probably I'm going to have like a VM in here as an attribute, okay? And then I'm going to need to create another table with my VM class, okay? And so you see, as you're reading through the things, you can go through and sort of, now you might, maybe when you're reading it, you say, no, maybe VM isn't his own class. Maybe I'm going to just keep track of like VM RAM, VM, okay? But when you start thinking about it, then it usually can, doing it this way can help you sort of decide what you think the classes should be, okay? And so as you're reading through this, I go back to the assignment, you see that there's, each customer has a single VM. The VMs have a bunch of different attributes, which include the monthly rate, includes memory and storage. Okay, but then it says the customer must customize the VM based on the customer's needs. The customer must choose from the following web server. Okay, so then we read about the web server customization, which has some additional attributes, the file server customization. So this is kind of a clue that like, oh, customization, this is probably some kind of a subclass kind of a relationship. So we probably have like a basic VM class that has like just basic stuff like memory and storage. But then maybe we have a subclass that's a web server, and then maybe another subclass that's a file server, and then maybe another subclass that's a Bitcoin, okay? And in fact, I tell you right here in the problem that you should have a customer, a VM, a web server, file server, and okay, so I tell you what the classes are. So very quickly, you should be able, and then you see, it says, you may use all public variables for the assignment. Okay, so I'm going to be putting in a lot of plus signs in my UML diagram. Each class should have a constructor and stro methods. I can add those to my UML diagram. Okay, make sure that the constructor for the customer class, okay, so this is implementation thing that I don't need to worry about here. Okay, here's another method, compute cost. I can add that to my UML diagram. There's a compute monthly bill method that's required. I can add that to my UML diagram, okay? So you can see that I can very quickly go through and build this UML diagram. And if we go back here to, oh my heck, what the? Okay, if we go back here to this, okay, we see that there's a very clear kind of correlation between what my actual code looks like, at least sort of the beginnings of my code, and the UML diagram, okay? So like if somebody were to just hand me this UML diagram and say, okay, write some Java code for this, or sorry, Python code for this, get my languages confused. But even if they said write some Java code, I could do the same thing. The point is that you can go in and I can immediately say, okay, circle class, this is class circle. All right, these are my attributes. So I'm going to do def underscore underscore init. I'm going to accept a parameter. I'm going to do self.radius, self.area equals these things right here, you know. So you can go through and very quickly start kind of creating a template for your code based on what you see in the UML diagram, okay? All right, now I want to show you one more thing. I'm going to completely switch gears, for not talking about UML. There's one thing that I neglected to show you earlier, okay? And this is something that is important, okay? So let's see, last time we had movies and then we had animated movies, and that's the only subclass we made. So we had movies and animated movies, okay? And we created an M1 and an M2 and an A1 and an A2. All right, so I'm gonna go ahead and run this code in a separate window. So I'll do Python 3 lecture 9.py, and I'm gonna run this with a -i so that we have all of the stuff still in memory. Oops, Python 3, not Python 4. Okay. So there we go. So it ran all this stuff. And so now, like if I do M1, you know, or print M1, I can see there's my different movie objects and print A1. Okay. The thing that I want to show you that's really interesting about inheritance is, do you remember the isInstance method? Okay. So we used isInstance to check what type of, you know, basically the data type of a thing. Okay. So if I did isInstance M1 list, okay, it would say false because M1 is not a list. What is M1? M1 is a movie. So if I said isInstance M1 comma movie, okay, that returns true, okay, because M1 is of type movie. All right. Now, if I look at A1, okay, remember A1, if I go back to my code, A1 is actually an animated movie, okay? So as you would expect, if I do isInstance A1 animated movie, okay, that returns true because A1 is an animated movie, all right? So this is the million-dollar question. What happens if I do this? isInstance A1 movie. What do you think that will return? Will that return true or false? Any guesses? Okay, one person says true. Okay, there's another true, 2 votes for true. True since it's inherited. Okay, well, as you can see, yes. Okay, so an animated movie is still a movie. So in the case of is instance, that will work. Now, there were a couple of people in the last assignment who, rather than use is instance, used the type operator, right? So if I do type M1, okay, it says, oh, it's this movie class, right? If I do type A1, it says it's an animated movie, okay? If I do type M1 equals movie, okay, then it says it's true, all right? And if I do type A1 animated movie, it says it's true. So the $1 million question is, if I do type 1 equals movie, what do you think that will return? Somebody says false. Any other guesses? Okay, well, you're right. It does return false, okay? So the nice thing about is instance will return you true for all of the different inherited things that your subclass is, okay? So if you have a subclass, so like let's say after animated movie, we had even a subclass of that called Japanese animated movie, okay? Japanese animated movie would be a Japanese animated movie, it would be an animated movie, and it would be a movie. All of those would be true if used in is instance. But if you tried to do type on those, it would only be a Japanese animated movie and not any of the other two, okay? So that's kind of the difference between using type and using is instance, okay? The reason why I bring that up is because in your assignment, if we go back to the programming assignment, you will see that in the description, it says right here, make sure that the constructor for the customer class checks to make sure that a passed-in VM argument is in fact a VM object, okay? Well, the passed-in object doesn't necessarily have to be just a boring VM object. It could be a web server VM. It could be a file server VM. It could be a Bitcoin miner, okay? But the point of me showing you what I just did is that if you just do an is instance for VM, it will handle all of those cases, okay? So in other words, when you are doing your test to see whether or not the constructor for the customer class, whether that VM argument is the right type, all you have to do is just is instance, whatever that argument name is, comma, VM. And as long as it's a VM, it doesn't matter whether it's a normal VM, web server, file server, or Bitcoin miner, it will accept it. Okay? All right. So that was the kind of the last thing that I wanted to tell you about for the assignment. The other thing that I'll tell you about the assignment, and it's kind of mentioned here in the text, but it's worth pointing out, okay? It'll say things like, you can choose up to an additional 120 gigs of memory, okay? And then I say right here, pay attention to this, for this assignment, you don't have to check to make sure that this ceiling of 120 gigs is met. Okay, that just adds in a lot of complexity that detracts from what I'm trying to teach. So even though it says you can choose up to 120 gigs, you don't have to account for that in any way. So in other words, somebody could add in, 7 million gigs if they wanted to, and I'm not going to make you check that condition to prevent them from doing that at this point, okay? And that's the same thing for down here, okay? The maximum amount of storage is 1,024 terabytes. I'm not going to make you check to make sure. If somebody tries to create, 10 billion terabytes, your object will be able to accept that, okay? And then same thing for a VM can support up to 8 GPUs. Again, you don't have to explicitly, check to limit that it's 8. If somebody tries to create a Bitcoin miner that has 400 GPUs, okay, they can do that. All right. So all that does is it just makes the code a lot simpler. You have to do a lot less work for the purposes of this assignment. Okay. All right, so that is all I wanted to go over today. It is 7:51, so we've got 9 more minutes. I will now take whatever questions about either the lab, the assignment, or anything that I've talked about that you would like me to answer. So go ahead and stick it in the chat or just yell it out. Will UML be on the quiz? I don't even know when the next quiz is. It is very, very unlikely that I will ask you to draw a UML diagram. Okay. In fact, I'm just going to say it right now. No, UML. Now, when you ask if it will be on the quiz, what I might do, I'd say what is likely that I'll do is I will give you a UML diagram and say, given this UML diagram, write a bunch of Python code. Okay. That's very likely that I'll do that. But I will not ask you to actually, I'm not going to give you a scenario and say, write a UML diagram. Okay. I will not do that. Okay. But I can almost guarantee you, having done this, I don't even know how many times now, I'll give you a UML diagram and say, all right, based on this UML diagram, create a complete working Java class that, you know, incorporates all the stuff that's in the UML diagram. Okay. All right, any other questions? All right, what I will tell you is start working on the assignment early, okay? Because you're bound to kind of run into some issues and you don't want to wait until Saturday or so. The problem with trying to get a hold of me at Saturdays or Sundays is if I'm doing something else, if I decided to go out hiking with my dog or, you know, whatever, then I might not answer you for quite a long time. So get started on it sooner rather than later. So if you run into issues or run into problems, you can ping me or you can ping Maddie for questions. Okay. All right. If nobody else has any other questions, then we will be done about 7 minutes early, and I will see you guys on Tuesday. All right. Yes. No problem. Have a good evening, everybody. Okay, somebody says, I'm working on the assignment, but I'm stuck on the formula in the compute cost. Okay, which formula in particular? The cost $20? Okay, well, there isn't really a formula for that. It's just $20. Right? So if you just have a VM, a basic VM, then basically all of the information in there is static. Okay? I think, let me pull up the assignment here really quick and look. So here's what it says. It says all VMs have a flat monthly rate of $20, which includes 8 gigabytes of memory and 20 gigabytes of storage. Okay? So if all somebody selects is a VM with no customization, just a normal basic VM, okay, then the compute cost for that is $20. That's it. Okay. Likewise, the amount of RAM for that particular VM is 8 gigs, no matter what. You shouldn't even accept any arguments for that because it's just always going to be 8. Okay. And the same thing with the SSD storage. It's just going to be 20. Okay. Where it becomes more interesting is when you start getting to the different customizations. Then you have to actually do a little bit of math to calculate how much additional on top of the $20 you would end up paying. Okay. So I'm not sure if that answered your question or not, but that's, I guess, the best way to explain it. Let me just give you one here. I'm going to share my screen again. Share. Okay. So, all right. So if I go back to here, okay, one of the things that I'll point out is, so let's say that somebody chooses this web server VM customization. Okay. So they choose the additional amount of memory they want at a monthly rate of $10 per 8 gig increments. Okay. So let's suppose that somebody said, all right, I want an additional 80 gigs of memory for my web server. Okay. Well, since that's billed at $10 per 8 gigs, then 80 gigs would be an additional $100. So the total cost for this web server VM would be $100 for this extra RAM, plus it would be the $20, which is just the flat monthly rate that everybody pays for any kind of VM. So the total price for this web server would be $120. $20 for the base VM, and then $100 for the additional 80 gigs of RAM that you want. Okay. So likewise with the file server VM, all right, it's $5 per terabyte or $2 per terabyte. So let's say that I get an additional, 100 terabytes. Okay. Well, that would be an additional $500, right? $5 per terabyte, so 100 terabytes would be $500, but that would be on top of the flat monthly rate of $20. So a file server with this $5 per month for magnetic storage would be $500 plus the $20. So the total cost for that would be $520. Okay. So did that answer that question for you? Hopefully. Maybe you're not there anymore. I don't know. I'll figure it out. Okay. Well, if you have any questions, just hit up myself. I will be happy to try and help you. Okay. All right. Anybody else have anything you want to ask? Because if not, you may leave. All right. You too.